sixth grade. Happy Easter. He is risen. He is risen indeed. I hope that you've had a wonderful 3-day weekend and are ready to attack this short week with joy. So today, this week, we are going to be focusing more on kinetic and potential energy, and you will actually be calculating your own personal kinetic and potential energy, which means that you have to understand all the terms that go with it. Speed, velocity, mass, gravitational constant, acceleration, all of those things. And so I'm here to hopefully help you understand those things a little better. So as you can see, today it says enjoy your day. Tuesday, it says lesson over calculating potential and kinetic energy. This is that lesson. Hooray, you're on step 1. Great job. And then it says notes and turn in the notes in Edpuzzle. So attached to this, you're going to have these notes that you're going to be filling out. And there's also an Edpuzzle that you're going to take. Notice it's only like a 2.5-minute video, so it should go quickly for you. And if you pay attention during this video, you should be able to fill out the notes as soon as we're done. So hopefully today's work won't take you too long. Please remember that Discovery Education is your friend. It has lots of great resources to help you understand this information. But you can also use the notes sheets that I've attached to past assignments, okay? So you have lots of resources to help you succeed. One of the biggest things I want you to know as we work through our energy notes is that law of conservation of energy. It says the law of conservation of energy states energy can neither be. I paused because I was hoping that you right there were finishing the statement for me and you were writing in the words can neither be created nor destroyed, because we cannot create energy, we cannot destroy energy. The creator of all things, God, gave us all the energy we should ever need here on this planet, and we are always recycling it. That's why it says but it can change forms. So all of our energy that we have on this earth is already here. We're not creating it. But we're also not destroying it. A lot of times it feels like we are destroying things left and right, especially energy. We feel depleted after we run a mile, but we're not actually destroying our energy. We're just changing the form of that energy. That stored chemical energy inside of our bodies was transferred into kinetic energy to cause us to run, and therefore we felt like we were depleted of energy because we changed our forms of that energy. Please notice that you're expected or asked to add an image or a video that emphasizes or highlights this statement. These notes are for you to study from and to utilize. So the more you add to your notes, the better it will be for you. And so it tells us if you're on Discovery Ed's kinetic and potential energy pages, they'll be helpful to you. When you hear about working and energy, like I've said in the last lesson, a lot of you might think of homework as work, but according to our scientific definition of work, work means that it's a change in the system, an actual movement of something. So homework is not necessarily work according to the scientific definition. However, when a leaf falls to the ground out of a tree, when a dog wags its tail, if I throw a ball up and down, those are all work because I'm changing the state of something. It moved, it changed location. And so those are all examples of kinetic energy in work because things are moving, okay? So work is already happening. Now, we know that energy can change forms. So kinetic energy, that falling leaf, can transfer into potential energy, and potential energy can transfer into kinetic energy. And so that energy transfer is always happening. And I love it because if you click on the energy transfer word, it takes us to our glossary, and it talks about energy transfer just from the last unit that we studied, that most of our energy comes from the sun. Plants absorb this energy from the sun. It transfers it to chemical energy in the plant, which then gets eaten by other animals and enters our food chain, okay? And so we have our energy transfer happening up through our food chain. We have a hot stove that passes its thermal energy to whatever is touching it through the process of convection, conduction, and radiation. So energy is transferred in so many different ways. It's transferred through the water cycle, thank goodness. So we always have energy in this world. So energy transfer is incessantly happening, but it's not because we're creating new energy. We're just recycling what's already there. So as you think about kinetic energy, I want you to understand that there's more than one type of kinetic energy, that there are many types of kinetic energy, and I want you to think about that. But also when we're calculating kinetic energy, you have to understand other words. Speed is how fast you get a certain place. If it takes me 8 minutes to run a mile, or well, we're going to change that. We're going to change it to kilometers because we usually in science we use the metric system. So if I want to know how many meters per second I'm going, that would be my speed that I'm looking at. So let's say that I went 10 meters in 5 seconds. I would be able to calculate my meters per second by taking 10 divided by 5 and coming up with 2 meters per second. Okay, so your speed is how fast you get somewhere, and you can calculate speed by taking your distance divided by your time. Okay, now velocity is only slightly different. Velocity is only different because you're also including direction. Okay, so velocity includes direction, but otherwise you calculate it in the same way as speed. So then there's force. Okay, so anytime we have an unbalanced force is when work can happen. So for example, if I were standing still and Finn came up and tapped me, I'm probably still going to be standing still. If I'm standing still and Finn comes running at me full force and knocks me from behind, I might fall over. Okay, that's an unbalanced force which caused acceleration from me, and it made a change in my velocity. I went from 0 velocity to moving velocity. Okay, now the more mass, which is the amount of matter that something has, so a lot of times we call it how heavy it is, but the amount of matter that makes something up. So for example, an empty plastic Easter egg has a lot less mass than a plastic Easter egg full of jelly beans, okay? Because there's more matter inside that jelly bean filled Easter egg. Well, if I had somebody throw an empty plastic Easter egg at my head, bonk, I might be like annoyed and like, what are you doing? But I wouldn't hurt. Now, if somebody took a jelly bean filled Easter egg and threw it at my head, there's going to be more force hitting my head, and I'm going to be a little upset about it. But something else, if I were to take an empty plastic Easter egg and put a small amount of force on it, like blowing, I might be able to roll that Easter egg across my kitchen table. However, if I had that Easter egg filled with jelly beans and I tried to blow on it, it's not going to go anywhere because it takes more force to get more mass moving. So we have to think about all that when we're calculating kinetic energy. So when we calculate kinetic energy, or how much energy something that's moving has, we use the formula kinetic energy equals mass times velocity squared divided by 2. A lot of times people will look at that as, and it's in your notes already, as kinetic energy equals 1/2 times your mass times velocity squared. Okay? Now when we do 1/2 on our calculator, if you just use 0.5, that is really helpful. So you might want to think about it as kinetic energy equals 0.5 times your mass, okay? And we usually calculate our mass in kilograms. Now, that being said, how many of you know how much your mass is in kilograms? Most of us do not know, okay? But if you know that there are 2.2 pounds in every kilogram, then you can easily find your mass. So for example, if I were to say, hey, I weigh 130 pounds, okay, and I know there's 2.2 pounds in every kilogram, okay, well then I'm just going to simply take my calculator, okay, and I'm going to take 130 divided by 2.2. Okay, now I know that my mass is approximately 59 kilograms. Ta-da, I calculated my mass. All right, now, so therefore I know that my kinetic energy equals 1/2 mass times velocity squared, right? So if I had 0.5 times 59, that's great. Now let's say that my velocity was, like I said before, I was traveling at a speed of 2 meters per second, right? So I'm just going to put 2 here, but my 2 is squared. So that's the only part that I am squaring. Well, that's easy because 2 times 2 is 4, right? So that's an easy one. So in other words, I know that I'm taking 2 times 2, which is 4. So I'm going to do 59 times 4 times 1/2. So again, I'm going to look at that calculator that I had pulled up, and I'm going to take my 59 that I have here, I'm going to multiply it by 4, and then I'm going to multiply it by 0.5, and ta-da, I've already calculated my kinetic energy of 118. Okay, now when we find kinetic energy, we know that units matter. And so if I were to just use all those units there, I would have that this is kilograms and that this is meters per second, right? Well, kilograms times meters per second, that's the same thing as saying joules. And joules is just a measurement of energy in science. So I'm going to say that my kinetic energy, if I were moving at a speed of 2 meters every second, would be 118 joules. Okay, so that's how you calculate kinetic energy. Now, joules is what we use anytime we measure energy. So if I were to take that same mass, 59 kilograms, and I wanted to calculate my potential energy, I would say, cool, well, my potential energy, if I were standing at a height of 2 meters, which is 6 feet, okay, I know that I have to take mgh. Well, what in the world is this g? Okay, that seems odd. Well, g stands for gravitational constant. And our gravitational constant in this world here on Earth is 9.8 meters per second per second. Okay? That means everything that's falling in our world because of our gravitational pull is falling at the speed of 9.8 meters every single second. It's accelerating at that speed. Okay? So that's pretty crazy. But that's important to note, okay? So when I'm jumping from a height of 2 meters, I have to consider that gravitational constant because my potential energy says mass times my gravitational constant times my height. Okay, so if I were calculating my own potential energy, I would say, great, my mass is 59 kilograms times that gravitational constant of 9.8 meters per second times my height of 2 meters. So again, I would just come and I would plug that right into my calculator, 59 times 9.8 times 2. And when I'm all done, I am going to have my calculation right here of 1,156.4. So as I said before, that would be 1,156.4 joules, because when we're calculating our energy, whether it's potential energy or kinetic energy, the unit we use in the end is joules. That's how much energy is tracked. So in other words, what I'm saying to you is if I'm moving at a slow speed, me, Mrs. Mick, if I'm moving at a slow speed of 2 meters per second, you would much rather me run into you at 2 meters per second than to fall on you from 2 meters in the air. Okay, so in other words, me falling on you from a height of 2 meters is much better than me running into you from a speed of 2 meters per second. So I want you to think about those things. So potential energy is that stored energy we know, and that's talking about the energy that is potentially going to happen. And that can be gravitational potential energy, right? Where something is falling from something else. It can be elastic potential energy that comes from like the pulling of a bow and arrow. It can be chemical potential energy like you saw in that Flipgrid Friday episode of the Alka-Seltzer had stored chemical potential energy. So there are many different types of potential energy and they can transfer into that moving kinetic energy. And this is just one way to calculate it. So the potential energy that we are calculating here is gravitational potential energy. So we have to understand speed and velocity in our units that we use and understand that gravitational constant. I ask you to tell me 3 or more types of kinetic and potential energy and give me 3 or more real examples of both of those things as well. Pictures or words will work for me because these are your notes, so I want you to make them in a way that makes sense to you. I will attach some readings to here as well in case you're still feeling confused or discouraged, but I hope that this video and the Ed Puzzle that you watch helps you to understand Thursday's assignment as well, where you will be calculating your own potential energy and your own kinetic energy. Thank you and have a great rest of your day.